So we continue with sound, and we are on the third part of the chapter, that is characteristics of sound and their subjective and objective nature. So uh, see, it is always seen that whenever you are listening to a sound, you can easily identify. In case of, suppose you are listening to a music, you can identify, okay, this is the sound of a piano, this is the sound of a violin, or this is a whistle of somebody, or the whistling of somebody, or this may be like, so basically you are able to find out that what is the instrument being played. Similarly, if you can identify whether it's a loud sound, or it's a feeble sound, or it is a high pitch or shrill sound. So all these are the different characteristics of sound. So sound can be characterized in three different forms. So the first one is loudness, the second one is the pitch, and the third one is quality, also called as timbre. Okay, so uh, that's why we have got loudness, pitch, and quality or timbre as the three characteristics of sound. So any particular sound can be identified based on these three characteristics. Loudness of the sound is going to identify whether it is too loud, or it is feeble, or whereas in the pitch will tell you whether it's a shrill sound or a flat note, and in case of quality will tell you that whether it is from which instrument, or whether it is when you are just walking by and somebody shouts your name from behind, you can identify, okay, oh, that is my this friend who has called me. Or even just when you give a phone call to somebody, and you can identify them from the person who is speaking, that okay, this is this person speaking. So that person need not even tell that it is he need not identify himself, and it is possible to just identify him by his sound. So this is because of the quality or timbre of the sound. So characteristics of sound: two sounds can be distinguished from one another by the following three different characteristics: loudness, pitch or shrillness, and quality or timbre. The above characteristics of given sound can be obtained from the wave pattern of that sound. Figure 7.1 shows a setup to obtain the wave pattern of the sound waves using a microphone and a cathode ray oscilloscope, CRO. So that is this particular cathode ray oscilloscope. अगर तुम लोगों ने देखा नहीं रहेगा, but oscilloscope का one of the easiest kind of application is in the medical industry, जहाँ पे तुम लोगों ने बहुत सारे मूवी में देखा रहेगा कि हार्ट रेट ऐसे ऐसे दिखा रहा है, and then suddenly when the person dies it is just becoming flat. So that screen, that small screen which is giving you that heartbeats over there, is nothing but a cathode ray oscilloscope. So that similarly, if when it is connected to the heart, it is giving you the heartbeats, or it is connected to a mic, then it will give you the waveform of the speech, what is being there over there. So whether it is some music or something, it will give you the waveform of that particular sound. So sound to be studied is produced before the microphone connected to the Y input of CRO. The wave pattern of the sound displacement time graph is obtained on the screen of the CRO. So when it is connected to the CRO, the CRO will give you the wave pattern of the sound which is being produced by that particular instrument. So that is why we can see we can use a CRO, that is cathode ray oscilloscope, for the viewing, or you can study of the different waveforms of the different instruments or different person or any particular sound. So let's see one by one the three characteristics over here: loudness, pitch, and the quality or timbre. So first of all, let's see loudness. Now the loudness is going to be dependent on the amplitude. The amplitude of the wave is going to determine the loudness of the sound. That means if I got two waves over here, this is one wave, this is another wave. Oh, this one wave is like this, okay, and the another wave over here is like this. You can see the frequency over here and the frequency over here. That means the time period and the waveform over here is the same. This is the same time period and this is the same wavelength also. So whether it is a displacement time graph or distance time graph, both the cases you will find that this, but the A over here is different and A over here is different. So this A being greater, this way, this is B and this is A, so we'll find that the loudness of B is greater than loudness of A. So loudness is going to be directly proportional to the, or we can say the loudness is dependent on the amplitude of the waveform. So if the amplitude is greater, the waveform, the sound will be of a loud sound. So we can define loudness as loudness is the characteristic by virtue of which a loud sound can be distinguished from a faint one, both having the same pitch and quality. So both have got the same pitch. The pitch is the same, that means it has got the same frequency, and the quality, that means the shape of the waveform is also the same, but the amplitudes are different. That means it tells me that B wave, the B sound is a louder sound than the A sound. Take a tuning fork, strike it softly, you will hear a feeble or soft sound. Bring it in front of a microphone, sketch the trace you observe on the screen of the CRO. Now strike the same tuning fork hard, and a loud sound is heard. Bring the tuning fork near the microphone, again sketch the trace observed on the screen of the CRO. Figure 7.18 shows the two such sketches. In figure 5.18, the two waves have same frequency and same waveform, sine wave, but they differ in amplitude. Obviously, the loud sound corresponds to the wave of larger amplitude. So that is what we saw, that this one, the frequency is the same, the time period is the same, but what is different is the amplitude. The amplitude over here is much greater than this one. Hence, it is seen that the B sound is louder. Similarly, if the key of the piano is hit hard or a pipe is blown hard, we impart more energy to the vibrating system, due to which the amplitude of vibration is increased and a loud sound is produced. Thus, loudness of sound depends on the amplitude of the wave. So, loudness is dependent on the amplitude of the wave. Intensity. The intensity of sound at a point of a medium is the amount of wave energy passing per second, normally through an unit area at that point. Its unit is watt per meter square, and the intensity of ordinary sound is nearly 10⁻⁶ W per meter square, while minimum intensity of sound audible to ears is 10⁻⁻12 watt per meter square. Greater the energy carried by the sound wave, greater is the intensity of the sound. The intensity of sound wave in air is proportional to the square of the amplitude of vibration, the square of the frequency of vibration, and the density of the air and the velocity of the air sound in air. So you see over here that loudness is one thing, that is about the amplitude, but the another thing, that is the amount of energy which the sound wave has got. That amount of energy which the sound wave has got is called as the intensity of the sound. So the intensity of the sound will be the amount of energy which is going to be given out per meter square. So that is watt per meter square is the unit of intensity, and it is seen that we are able to hear intensity of sound of 10⁻⁻12 watt per meter square as the minimum sound level which we can hear easily. Now intensity of sound is going to be dependent on 4 factors. First one, intensity is directly proportional to the square of the amplitude. Okay, it is directly proportional to the square of the amplitude. Secondly, intensity is also proportional to the frequency square. Okay, square of the frequency of vibration. The third thing, it is proportional to the density, or we can say rho, I will take it as rho, the density of the air or the medium, and finally will be proportional to the velocity of the sound in air. So it is velocity, density, frequency ka square and amplitude ka square. So the intensity of sound is dependent on these four factors, whereas the loudness is dependent only on the amplitude. That's the difference between the loudness and the intensity. So it can be seen that loudness and intensity, they are different in the form that loudness is a subjective quantity, whereas intensity is an objective quantity. What do you mean by subjective quantity and objective quantity? Subjective means subject, yani person. When it is dependent upon person to person, when loudness will be dependent on person to person. It will depend upon the hearing capacity of the person. It depends upon the mood of the person. It depends upon what is being playing at that time, where जिसके कारण वो loudness का feel आएगा. So loudness is a subjective quantity which cannot be measured but it can be felt. Okay, loudness is something which can be felt but it cannot be measured. Whereas intensity is something which can be measured and you can identify that okay, this is a loud sound and a louder intensity or higher intensity and a lower intensity of sound. So measurable quantity is always an objective quantity. Objective यानी क्या? It is object, यानी वो living thing के ऊपर dependent नहीं है, वो एक particular number से related है कि okay, these many decibels, okay, ये इतना मीटर, ये इतना. So that all values are certain things which are not dependent on person to person. Okay, so when any particular thing is dependent on person is called as a subjective quantity, where something which is measurable and can be easily found out by measurement, then it is called as a objective quantity. So in this case, we find that the loudness is a subjective quantity. Now, how it is a subjective quantity? Take a simple example that you are in a party. Okay, you are in a mood of partying and you have got good friends around you, and then you have got a loud music going on. So and according to you the music was not loud because somehow you could not increase the volume of that particular thing for more than a particular thing, and you wanted it much more louder, but it was not loud at all. So because for you wanted to dance and you wanted to enjoy, and that's why the music was not loud. But consider senior citizens or even your parents may be in the next room, and what will happen, they are trying to sleep and they are getting disturbed by that particular sound of yours, where the sound which you feel is not even loud enough, they are going to definitely feel is loud. Similarly, if your parents are playing a music which is old song which you don't like, then definitely for even if they have got it at a sober volume of the stereo, you will find that arey yaar kitna loud hai, why don't you, I am not able to concentrate on my studies. So definitely something at a particular time is considered to be loud because you are not in that mood or you are not in that condition to accept that sound, and that's why it is becoming loud sound. But the same sound or even higher than that may not be felt as a loud sound when you are in a mood to enjoy that particular thing in a different manner. So that's why it is a subjective quantity. Okay, so you see that loudness of a sound depends on the intensity, that is the energy conveyed by the sound wave near the eardrum of the listener, and the sensitivity of the ears of the listener. So of course, it is going to be dependent upon the intensity which is reaching the ears. At the same time, it is also dependent on the sensitivity of the ear. If the person is deaf, then of course it doesn't matter to him at all, kitna bhi loud bajao. So that's why it will be the intensity of this listener. Thus, the loudness of the sound of a given intensity may differ from listener to listener. That is, the sound of the same intensity may appear to be of a different loudness to different person. Further, two sounds of the same intensity but of different frequency may differ in loudness even to the same listener, because the sensitivity of ears of the person is different for different frequencies. So, certain frequencies are not audible, or you can say these ears are not sensitive to all the different kinds of in the different kinds of frequencies. So if the frequency, intensity is related to frequency. So if a certain frequency of sound is there which the person is slightly less sensitive to, then in that case it will not be loud sound for that particular ears. So for normal ears, the sensitivity is maximum at a frequency 1 kHz. The sound wave loudness, for the sound wave, loudness has a subjective nature, that is, it depends on the listener, while the intensity, being a measurable quantity, has a objective nature. Now let's see what are the factors affecting the loudness of the sound. This is a very important thing. So let's see first one. Loudness is proportional to the square of the amplitude. So first of all, because we are having the same thing, so loudness, we had seen, initially what we have seen was the intensity. Now we actually see how is the loudness going to be dependent on factors affecting loudness. So the first factor is loudness is directly proportional to the square of the amplitude. So when the body vibrates with a greater amplitude, it sends forth a greater amount of energy, and hence the energy received by the eardrum is large, so the sound appears louder. So more the vibrations, more the amplitude of vibrations, more will be the loudness of the sound. So that is quite easy to understand. Second is loudness varies inversely to the square of the distance from the sources. So it is going to be, loudness is proportional to the square of the distance between the two objects. So that means if I am standing here and a complete band of the वो शादी का band रहता है वो मेरे बाजू में बज रहा है, तो of course definitely it is going to be too loud. But if I am at a distance from there, I will not find it to be too loud. So that's why it will be inversely proportional to the square of the distance. The more the distance, lesser will be the loudness. Nearer the distance, more will be the loudness. So if the listener is close to the source of sound, he hears it quite louder. But if he is far away, the sound becomes feeble. If we move further away from the source, a stage we reach when the sound becomes inaudible. Thus, closer the source, louder is the sound. We move on to the third point, that is loudness depends on the surface area of the vibrating body. So in the surface area, loudness depends on the surface area. So it is, loudness is dependent on the surface area of vibration. Now this is very easy to understand. Now you know that there is a drum which is so small and we are banging it. कितना भी hard bang करो फिर भी इतना loudness नहीं होगा. But वही चीज वो लोग movies में दिखाते हैं ना कि पुराने ज़माने में ऐसा वो when they wanted to announce something, they have big drum and that thing he just hits it with a hammer and doom 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 करते हैं. तो क्यों? Because it will be a louder sound which will produce. Because why is that so? Because the drum being bigger, the vibrating membrane which is there becomes bigger. So bigger the membrane, bigger will be the sound, louder will be the sound. So that's why we see that a large vibrating area sends forth a greater amount of energy, and larger the surface area of the vibrating body, louder is the sound heard. For this reason, the bells in the school, temples, etc. are made big in size. So you'll always find that the church bells and all, they are big ones. Why they are big ones? So that the sound is heard, which is larger sound. When a tuning fork is sounded in air, the sound given by it is feeble. But when it is placed on the table, the sound becomes much louder. The reason is that the tabletop provides comparatively a larger surface area of air to vibrate, and so the sound energy reaching our ears increases. Similarly, in the case of stringed instruments, the sound chamber is provided to increase the volume of air to vibrate, and hence the loudness of the sound increases. So you can see that not only in the church bells and the school bells, but also in case of the tuning fork, if I place it directly in the air and the sound will be not so high. But the same thing when I put it on the table, the vibration of the table and the air column around it will be increasing. Hence, it is going to give you a louder sound. Similarly, is the condition for the stringed instruments. You can see guitar and all; they will have a larger volume. That is the air sound box behind it, so that the louder the sound box, the more will be the loudness of the sound. So that's why the vibrating body, the air column is increased. By increasing the air column, you are increasing the loudness of the sound. Fourth point, loudness depends on the density of the medium. So the fourth point is loudness is dependent on the density of medium. Okay, so if the density of medium, it is going to depend on the density of the medium. More the density of medium, more will be the loudness, because the sound will be able to travel more easily in a denser medium. Hence the loudness will be more. So more the density of the medium, more will be the loudness. And finally, loudness depends on the presence of resonant bodies. So what are resonant bodies? So it is going to depend on the resonant bodies around, because if there are more resonant bodies around, the resonant bodies will always vibrate with a higher amplitude, which will give you more sound. So अगर आजू बाजू में resonant bodies ज़्यादा है तो automatically it is going to give you a louder sound. So the presence of resonant bodies near the vibrating body increases the loudness of the sound. So these are the 5 different factors on which the loudness of the sound depends. The loudness of sound depends on the amplitude, square of the amplitude. It is inversely proportional to the square of the distance between the source and the listener. It is proportional. It is dependent on the surface area of vibration. It is dependent on the density of the medium, and it is dependent on the resonant bodies around this particular thing. So this gives you the factors affecting the loudness. Now, talking about the relationship between loudness and intensity, although loudness of sound depends on intensity, but loudness is not the same as intensity. Intensity is a measurable quantity, while loudness is a sensation. Experimentally, Weber and Fincher established a relationship between the loudness L and intensity I, which is given as L is equals to K log I. Now, this particular part of the thing is not there in the syllabus. It is just an additional information. So, you may cancel this part. There is no need. Only thing what you need to remember is that the units of the loudness and sound level is phon or decibel. So, loudness and sound level is measured in, it is measured in phon, or it is measured in decibel. So decibel and sound, which is called as dB. Okay, so decibel and that of the loudness is phon, and the level of sound is expressed in decibel. So we can just cut short this complete derivation and everything which is given over here about the log. So we cancel that. Thus 1 dB is defined as the increase in level of loudness by the intensity of sound, increased by 26%. You don't require this thing, so you can cancel this part. And also the different levels. Okay, we can just go through this thing because that is connected to noise pollution. So they are given that the different decibel levels of sound of different sound producing objects. So you can see that the takeoff of the jet plane is 140, which is the maximum over here, and that of a pin drop silence is 0 decibel. So these are the different things, different instruments or different machineries or things are going to give you the decibels. So it is considered that if the level of the sound is above 120 decibel, then we can consider it to be as a noise pollution. So however sweet the music is, but if the decibel is more than 120 decibel, then you consider it as noise pollution. So disturbance produced in the environment due to undesirable, loud and harsh sound of level above 120 decibel from various sources such as loudspeakers, siren, moving vehicle, etc. is called noise pollution. A constant hearing of sound of level above 120 decibel can cause headache and permanent damage to the ears of the listener. The safe limit of level of sound for hearing is from 0 to 80 decibel. Sounds of level 30 decibel and 10 decibel has a soothing sensation, while the sound of level 0 decibel represents the lower limit of hearing. So that's the thing, that normally whenever we are moving around any place, if the sound level is within 80 decibel, so that is 30 decibel to 80 decibel is the one, 0 to 80 is the safe limit of the hearing, and if normally when people are around, so 10 decibel to 30 decibel is soothing to your ears. It is not going to give you any harsh kind of a feeling. It is okay, means quite normal. And when it is going to be 0 decibel, it is like the lower limit of hearing. You can hear only like pin drop वगैरह जो है, that is 0 decibel. Note The limit of hearing should not be confused with the limit of audibility. The limit of audibility refers to the frequency range of the sound from 20 Hz to 20,000 Hz, which a man can hear, while the limit of hearing is the lowest level of loudness, 0 decibel, which a man can hear. So, of course, with the loudness, when you're talking about, we are not talking about the frequency. You can see they're nowhere connected to the frequency. So, loudness, when we are talking about, it is connected to only the decibels. That is only, it is not connected to the frequency. Whereas the audible sound, the waveform which we can hear, is from 20 Hz to 20,000 Hz, which is the frequency of their particular sound. So that's why we should not get confused about, or we can should not get jumbled up with these two things. So that is about the noise pollution and the audible sounds. We now move on to the next part of the chapter, and that is pitch. Okay, but I'll do it in the next video.